Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Muzammil Yaqub, lecturer, Department of Technology, and your instructor for this course, which is Materials and Methods of Construction. So let's start our today's. So now let's come towards our last part of this class. So here we will discuss about the properties of aggregates. So over here you can see in this picture the boy is indicating that we will discuss the physical properties here. So the main physical properties we are going to discuss here is strength. We will know about how to determine the strength of aggregate and what is the minimum strength we should require. Then we will discuss about hardness, and the third one is toughness. The fourth one is durability. We will know about the durability of aggregates. Then the fifth one is about porosity, right? So we will discuss what is porosity and how it affect the aggregate shape or aggregates physical property as well. And in last we will discuss about water absorption, right? How it affects the properties, means physical property of aggregates, and why it is so important. So let's start. The first one, as I discussed in the last slide, strength. So strength of aggregate, in practical majority of normal aggregates are considerable stronger, right? Stronger than concrete. Majority normal aggregates means in our daily life, right? The type of aggregates we are using, they are stronger than concrete, and the experiments prove that as well, right? So basically the test which is performed to check the strength of aggregate is known as compressive strength test, right? Or in other words, mechanical test, right? Mechanical means checking the mechanical properties of aggregate. So over here in this picture you can see the apparatus used for performing compressive strength of aggregates, in which we first place aggregates, and on the top of that we place plunger and apply load, right? So by this method we came to know about the strength of aggregate. So the good average value of crushing strength means strength of aggregate is 200 Newton per mm square, right? This is the ideal value, right? When you perform this experiment and you get value around 200, so it means that aggregate is much stronger, and it will give you high quality construction work, right? Or high quality concrete. So it was all about strength of aggregate. Now let's discuss hardness of aggregate, right? Hardness means, first we should know the difference between hardness and strength and toughness, because these three terms are much related to each other. So in previous slide we discussed about strength. Basically strength is the compressive strength, right? When you apply the load and compress the aggregate, right? So this is all about that compression behavior of the aggregates. And hardness, so hardness of aggregate is the ability, right? The ability of the aggregate to withstand wear or load applied or pressure, right? When you apply pressure or load on the aggregates from any direction, right? So it is known as hardness of aggregate. So for example the apparatus we are using to check the hardness of aggregate is known as Los Angeles apparatus, right? Los Angeles abrasion apparatus. Over here in this picture you can see the apparatus picture, how it looks like. So in this apparatus we have the means iron balls, 11 number of 11 iron balls whose diameter in 47 mm steel or iron balls, and we place aggregates in with these iron balls and rotate them, right? So by this method we find the hardness of aggregate. And if we talk about its satisfactory value, so a satisfactory aggregate should have an abrasion value of not more than 30%, right? 30% for aggregates used in wearing course or wearing surface. Wearing surface means top layer, right? For example, if you are constructing the road, so when you see the road, the first layer you see is called wearing course, right? And the 30% for wearing course, and 50% for aggregate used in non-wearing course, right? So this is a bit difference between the hardness level, as you can imagine why. So this was all about the hardness of aggregates, the apparatus by which we perform the hardness test on aggregates. So this was about hardness. Now let's move towards next physical property, which is toughness. So the toughness is resistance of aggregates to failure by impact, right? So this is a little bit difference. Basically the what this says means resistance of aggregates to failure by impact, and this property is defined by determining the or performing the impact test, right? Over here in this picture you can see the apparatus which is used for identifying the toughness of aggregate. And if we talk about its standard values, standard toughness we should know. So the or in other words impact value, so the impact value shall not exceed 45%. 40% of what? 45% by weight of aggregate used for concrete, or in other than means, for example, if you are using as a wearing surface, right, as I discussed in previous slide, so it should not exceed then 45%. And if you are using for concrete, so it should be around 30%. So this is also a very important property of physical property of aggregate, which is toughness, as I discussed. So now let's move to a next slide. So here we will discuss about durability of aggregate. So basically durability is the ability of the aggregate to withstand, right? Withstand means to resist or to bear, right? External or internal damaging attack. External means because of when you apply load, so it will produce changes on its external surface. And internal damages means normally it is caused by weathering effect, or by normally by water, which cause internal damages in aggregates, right? So it's also known as soundness of aggregate, right? The basic principle is the durability is depend on the type of rock we are using in the shape of aggregate, right? As I discussed in the start of my lecture about different type of rocks, means for example, if you are using igneous rock as a aggregate, so its durability will be different from of that type. For example, if you are using sedimentary rocks, so the durability of that both type of rocks will be different. And it is known as mineralogy. Mineralogy means different type of rocks, right? As I discussed three types earlier: igneous, sedimentary, and metamorphic rocks. And another important property is that porosity. Porosity means the number of void or hollow spaces inside the surface of aggregates is known as pores or voids, right? So when you check this property, so it is known as porosity. So basically these two are the main properties which define that aggregate will how longer last, or the durability of aggregate, right? So, or in other word, how it is likely to behave when you use the type of aggregate in construction or in concrete. So right, and the durability of aggregate is also checked by soundness test, right? So this was all about durability of aggregate. Now coming towards the porosity. As I discussed in previous slide, porosity means having pores of various sizes, right? So normally different type or different sizes of aggregates have different sizes of pores. Pores means empty spaces inside the aggregates, right? So for example, if we are talking about coarse aggregates, so its pore size will be different, right? And for example, if we are talking about and high weight aggregates, right, so its empty spaces will be different. So porosity means how aggregates or the amount of water absorb the amount of water will absorb aggregates, right, or aggregates will absorb water. So basically how it is performed, we have two ways to perform or to know about the porosity of aggregate. The first one is a weight percent of fully water saturated void. For example, you take let's say you took the 100-gram sample of aggregate and put into the right water. Before putting into the water, weight, let's calculate its weight, known as dry weight, and then put these aggregates in water, and after some time then calculate its water. So by this you can calculate the porosity of porosity of aggregates means subtracting dry aggregate weight from wet aggregate weight. So by this process you can know about the porosity. Another method is ratio of volume of voids to ratio of total volume of rock. So this is less preferable method. So in other words, the amount of water and its rate of permeation depend on the size and volume of aggregate as well. So this was all about porosity, right? Porosity means the amount of water will how much the amount of water will absorb the aggregate or not. So the last property is it's I think very much similar to the porosity, which is known as water absorption. Means as I discussed earlier, it is also determined by the same test procedure as porosity, right? So when you are performing this experiment, so your first step will be you should weight the aggregates, right? Then place them in an oven, right? After weighting the aggregates, place them in an oven at a temperature of 100 to 110 centigrade, and the time, for example, for 1 day means for 24 hours. Then remove them from oven and place them at a room temperature, so it get cold, and then take its weight, right, or calculate its weight. So it will be your second weight, means W2, and the formula which is used to determine the water absorption is that means for example over here you can see A means its first weight, right? And B means its second weight, means when you calculated the weight after putting means or after putting in temperature at oven, and divide by the second weight, right? And for obtaining its percentage, multiply with 100. So if we are talking about its average value, so water absorption shall not be more than 0.6% unit by weight. Unit means if you are taking the sample 1 kg, so it should not exceed the 0.6% of 1 kg. And for example, if you are taking the sample of 100 gram, so it should not exceed the 0.6% of 100 grams, and vice versa, means unit, right? Though whatever the unit you are using, right? So this was all about physical properties, and inshallah in our next lecture we will discuss about its chemical properties, means chemical properties of aggregate, and its gradation process, how aggregates are distributed in different sizes, and its crushing strength. So I think it's enough for today. So see you inshallah in next video. Take care and Allah Hafiz.